All right, our next section is section 7.3, absolute value equations. So now we're talking about an equation. So it includes an absolute value and a variable. So our example of that would be absolute value of x minus 3 equals 7. Okay, so there's two cases you have to always consider. You have to consider the positive case and you have to consider the negative case. Because remember when we did graphs, there was a flipped section, which is the negative case. When you think of this using a piecewise function, that would be like absolute value of x minus 3. It would be x minus 3 if x is greater than or equal to 3, or it could be negative x minus 3 if x is less than 3. So these are your two cases, again, your positive case and your negative case. So we also have to include those two cases when we're dealing with equations. So before we learn how to solve this algebraically, let's think about what the graph here would look like. So the graph of absolute value of x minus 3. This is a linear function that would have a slope of 1 and a y-intercept of negative 3. Let's start down at negative 3 and it would have a slope of 1. So it would look something like that. But also remember that this graph can't go into the negatives. So we would reflect that negative portion up into the positives, making that V-shaped graph. So the V-shaped graph has a y-intercept of 3, an x-intercept of 3, and again, the blue part here is the absolute value portion. Now, the equation is equal to 7. So what that basically means is I would need to find where this graph meets 7. So 3, 4, 5, 6, 7. So the line of 7 would be right here. So I need to continue on that absolute value graph to see where it meets 7. And those would be the solutions that I'm looking for. So it looks like one solution is at negative 5, because this point here would be at negative 5 and 7. And it looks like we have another point here at 10 and 7. So negative 5 and positive 10 look like my answers. Okay, well let's take a look at this algebraically. So algebraically, we're always going to write that you have a case 1 and a case 2. Case 1 is where your graph hits your original positive line. So that would just be x minus 3 equals 7. Case 2 is the flipped side, so negative x minus 3 equals 7. So again, this point over here is the flipped point, because that's on the flipped part of your graph, and that one there is part of your original line. So now we just go through and solve these as if it was any equation. So here we'll add the 3 over. So x equals 10 is one of my solutions. Here, I would put the negative in, so it's going to be negative x plus 3 equals 7. I'll have to subtract the 3 over, so negative x equals 4, and then divide out the negative 1, so x equals negative 4. So clearly my graph here was a little bit off. It should have hit right here at negative 4 and 7, just a poorly drawn graph. So those would be my two solutions. Now you can always check that these work by plugging them into your original equations. And remember, sometimes you might get an extraneous root. So here if I check, I go 10 minus 3 in absolute value signs equals 7. That is true. The other option is minus 4 minus 3 in absolute value signs equals 7. And that gives me minus 7, which when you bring it out does equal 7. So both one of my answers check. All right, let's try another example here. We've got absolute value of 6 minus x equals 2. So again, we're going to do our case 1 and our case 2. So case 1 is the positive case, so we have 6 minus x equals 2. Case 2 is the negative case, so negative 6 minus x equals 2. Just move things around, so I'm going to subtract the 6 over here, so we get negative x equals negative 4. Divide out the negative, so x equals 4. That's one of my answers. On the other side here, that negative needs to get distributed. So we have negative 6 plus x equals 2. I'm going to add the 6 over, so it looks like x equals 8. So there I have two solutions. And again, as always, we do need to check because sometimes we will get extraneous roots. So when I check, I'm going to plug that into 6 minus 4 equals 2. appears to work. The other option is 6 minus 8 equals 2. That'll give me absolute value of negative 2, which does equal positive 2. So both of my answers do check. Alright, our next example here is going to have an extraneous solution. So let's take a look at what that seems like. So as before, we'll do our case 1, and we'll do our case 2. In case 1, we're going to take the positive 2x minus 5 and set it equal to 5 minus 3x. So here, I'm going to maybe subtract my 2x over to the other side, and I'll subtract my 5 to be over here, which means I'm going to end up with minus 10 on this side and minus 5x on this side. Divide out the minus 5, so I'm going to get one x value of positive 2 as one of my solutions. Let's check the other side. So it's going to be the negative case, so negative 2x minus 5 equals 5 minus 3x. When I distribute that negative, we'll get negative 2x plus 5 equals 5 minus 3x. And again, combining things, so I'm going to maybe add my 2x over here, and then subtract my 5 over here. So we end up with 0 on this side and negative 1x on this side, which I can divide out the negative 1. So 0 is the other x answer. And we need to check these because I already know that something's going to be extraneous from the way the question was set up. So let's go and we'll plug that in to plug the 2 into the original. So when I go through and I plug in a positive 2 in here, I end up with 1 equals negative 1, and that is not true. So that one does not check, which means it's extraneous. The other answer here, when we plug in 0 for both of my x's, I end up with 5 equals 5, so that does check. So here we only actually have one solution, and that's 0 equals x. Please try this next one on your own, going through the exact same as we did in the previous example. You can pause the video here, and then I will show you the solution. You can go through the solution on your own and check that you got the right answers. Now our third example is pretty easy because it's an absolute value equation with no solution. So if you take a look here, I need to start by moving the 12 to the other side. So we get absolute value of 3x minus 4 equals negative 3. Now we know that that is not possible because you can't have an absolute value that gives you a negative answer. On a graph, what that would look like is it would have the V-shaped graph up top, but you're trying to hit it with a line at negative 3, so there's no way that they would ever touch. So there's no solution there. If we take a look at the next problem, same thing. If I subtract my 9 to the other side, we get 4x minus 5 equals negative 7. So you have to make sure then that you state that there is no solution. So I'd like you to stop here and please try page 398, number 4 and 5, ABC on both of them, and then we'll pick back up with the video. Okay, this is where stuff's going to get a little bit tricky because now we have a quadratic absolute value that we're looking at. So if you think about what this graph looks like, it would be a W-shaped graph, and we're going to figure out where that hits the number 1. So you could have as many as 4 solutions to this problem. There could be 2, there could be 3, depending on exactly where it hits, or there could be none. So there's a lot of different solution options. We still go through our same thing with case 1 and case 2. So in case 1, we're going to take the positive, x squared minus 2x equals 1. And when I move the 1 over, we get x squared minus 2x minus 1 equals 0. Now, how do you solve this? Well, you have to go through and either factor or use the quadratic formula. This one does not factor, which means we're going to have to go through the quadratic formula. So when you go through your quadratic formula, you should get 2 different options, either x equals 2.41 or x equals negative 0.41. Then we must perform the check to see if these work. Checks with decimals are going to be approximate. And when you go through a check, you should find that they both get the absolute value of 1 equals 1, which means both of these answers check. So now we need to continue on with case 2. So in case 2, we're going to take the negative version. So it's going to be negative x squared minus 2x equals 1. So here again, you have 2 choices. You can either distribute the negative in, but sometimes it's easier to divide out the negative to the other side. So we get x squared minus 2x equals negative 1. So then I add that 1 over, so we get x squared minus 2x plus 1 equals 0. And now this one factors nicely for us. So this one becomes x minus 1 and x minus 1. Again, giving us 2 of the exact same factors, which really means that we have one x-intercept at y. So we can go through, that is one of my answers, and then we just need to provide the check. And we should get the absolute value of negative 1 equals 1, and that is true. So here we have 3 solutions. All right, let's try one more. So this one we have a parabola that is meeting with the absolute value of a line, which remember this would be like a V-shaped graph. So let's take a look at what that would look like. So here just use Desmos to show you that the red graph is the absolute value part and the blue graph is the quadratic. And so where they cross looks like there's 2 places. It should get an answer of negative 1 and then an answer of positive 10. So let's figure that out algebraically. So let's start with case 1. We're going to move everything to one side, so I'm going to subtract the x over and add the 10 over. So we'll get 0 equals x squared minus 11x plus 10. This should factor to x minus 10 and x minus 1, which means I end up with 2 options, either x equals 10 or x equals 1. Now we'll try the other side again. We'll distribute that negative. So we get negative x plus 10 equals x squared minus 10x. Add my x over and subtract the 10 over. So we'll end up with 0 equals x squared minus 9x minus 10. And again, this factors into x minus 10 and x plus 1. So my 2 options are that x equals 10 and x equals negative 1. So notice I only have 3 options to check. I have 10, 1, and negative 1. So let's check those. So here, when you finish your check, it looks like the 10 does work. The positive 1 does not work. And the negative 1 does work. And that is exactly what we found in Desmos. So finally, let's finish off some assignment questions dealing with those quadratics. So please complete these. And there's a summary on the back side of your handout that is a good idea for you to look through as well. Thank you.